So, what if your AI power is determined by your RAM subscription? Think about it. Right now, the most powerful governments in the world are trying to gatekeep human intelligence by banning the chips. They want to believe you if you do not have a $40,000 NVIDIA H100, you are out of the game. You are legacy. They are wrong. They are fighting the last war. While the headlines are arguing over export controls, engineers right here in India are proving that software eats the hardware for breakfast. They didn't wait for shipment of banned chips, they are hacking the math. Today, I am pulling back the curtain on Indian quantization. This isn't a technical trick. It's the reason why India can win this massive race or run for LLMs on a hardware you can buy at local electronics shop. And if you want to stop being a consumer of AI and start being an architect of it, you need to understand this Indian quantization for your revelation. Let's go. Let's be real. We all know that getting us more GPU won't solve the issue. Actually, we have become really spoiled. We have so much cloud compute that we run everything in FP32, 32-bit floating point. It's like you are picking up a car to deliver a pizza. Uh, Imagine your GPU is a supercar, and you are stuck in Indian traffic. And most of the time, you wait for the signals to go through the traffic. And once the signal goes off, actually you can pass through the traffic. Imagine that with your data coming in. You spend almost 90% time waiting for your data to come from its VRAM to processing core. And this is the memory ward I am talking about. Now imagine if you could make the data 4 times smaller without losing the meaning of the model, then the traffic clears and you can use the data more efficiently. That is what most Indian startups are trying to do. They aren't trying to build bigger engines. They are actually trying to fuel more times, more models, and making it more efficient. Actually, FP32 is like Earth to moon precision. It measures down to the millimeter. But does a chatbot requires that much precision? Does it have to know the each specific characters to crack out a joke? No, that will be a slow. The INT8 rounds, those massive decimals are cut into small whole numbers. For example, 0.012 blah 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 could be cut down to 0.12. These whole numbers can be ranged from -128 to 127. It sounds like a downgrade, but we are making the model. We are not making the model more stupid. But here's the secret: neural networks are surprisingly resilient. They don't need perfect numbers. They need the right patterns. By switching into INT8, we drop our memory footprint by 75%. That means 70 billion parameter model that used to need a server can now fit into a workstation in our home. This is not just about saving the money, it's about sovereignty. The India AI mission is bringing 38,000 GPUs to our shores, but a lot of these won't be H100s. They will be smaller ones like L4, or L40s. If you try to run fat Western models on these cards, they will crawl. They weren't built for our hardware constraints. But Indian engineers are mastering hardware-aware design. They are using INT8 to ensure that our data never has to leave our borders. We aren't sending our healthcare data or our financial logs to a server in Virginia anymore. We are running it locally on optimized silicon at $65 per hour. Now let's check how this can be done. You are an engineer. You want to stop talking and start doing this stuff. So the industry standard is a three-step procedure. You take the model, take the torch weights, convert it to ONS, then convert to TensorRT. Think of PyTorch as the drafting table. It is where you experiment. It's heavy. It's for research. When you export to ONS, you are creating the blueprint. It freezes the model's logic. But the real magic happens in the TensorRT. This is NVIDIA's factory. When you run this, TensorRT doesn't just run your code, it re-architecture it. It looks at the transistors on your specific GPU and says, I can fuse these layers, I can rearrange this in this memory. The result, you are no longer running a generic model, you are running a custom tuned engine. But wait, there is a trap. 90% of the tutorials online tell you just to turn it into INT8. Don't do it. If you chop off the decimals, your model will start hallucinating. It will lose its mind. You need to do calibration. Calibration is when you run a small slice of Indian data through the model while TensorRT watches. It learns the range of your numbers. It figures out where to focus its 8-bit of resolution. If you calibrate an INT model using English data, you are already lost. Master linguistic aware calibration is what separates a rapper dev from a system engineer. Let's be honest. Market is flooding with people who can write system prompt. But there's a massive shortage of people who actually understand the inference optimization. If you can walk into a boardroom in Mumbai or a startup and say, I can cut your GPU bill 75% without losing a single point of accuracy, you just become the most valuable person in the building. The era of brute force AI is almost ending. We are almost reaching the saturation of the GPU or the hardware that we can use. The era of systems architecture is just beginning. And I think India shouldn't wait for the world to give us permission to lead. We should build the future on the silicon that we have. I have put my INT8 quantization and calibration scripts for lighter models in the description. Then try to learn from it and try to break the compute wall yourself. I am building this channel to document the real engineering, not the hype. If that's your vibe, hit the subscribe button and I will see you in the next one.